Good day, my dear students. So today we will be starting a new unit on dynamics. This is the third one. So in this video lecture, we will be able to cover the first two topics, which are net force and force equation. And in the next one, we should be able to cover free body diagrams and object analysis. System analysis is an optional topic. So let's start with the net force. Our basis for computations, for computing the net force, is the Newton's first law of motion. Let's have a review of how it goes. An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced force. Okay, let's take a moment to dissect the first law of motion. So an object at rest stays at rest. An object at rest is not moving, it's stationary. That means its velocity is zero. An object in motion stays in motion with the same speed and in the same direction. So if something is moving at the same speed and in the same direction, we can say that its velocity is constant. So when a velocity is constant, it's not changing. That means we don't have any acceleration. Acceleration is zero. So of course, it's if the object is not moving, it is at rest, its velocity remains to be zero for a time. Acceleration niya din is also zero since the velocity is not changing as well. So what does it take to accelerate an object? You need an unbalanced force. Okay, so if you want a body at rest to start moving, you need to give it an unbalanced force. You need to give it a big enough push. Okay, if you want an object that is moving at the same speed, let's say 5 meters per second to the east, and you want it to increase, to speed up or to slow down, you have to give an unbalanced force on that particular object. So we need to compute for the net force kasi there might be multiple forces acting on a particular object. If we compute that the net force is equivalent to zero, that means there is no unbalanced force. Since there are no unbalanced force, wala ding acceleration, or the object will not be accelerating because it is the unbalanced force that causes that. It causes the acceleration. When the net force is zero, that means the forces cancels out. Okay, nagka-cancel out yung aking mga forces. But if the net force is not equal to zero, there is unbalanced force. The forces do not balance out or cancel out, and the object will be moving or will be accelerating in the direction of the net force. Okay, so net force, we have several notations. F sub net is 1. If you want to be specific, F sub x and F sub y. So forces can act along the y and along the x-axis. So if the forces are acting along the y-axis, like this one, it's pointing upwards and downwards, so these forces are acting along the y-axis, we use F sub y, and F sub x if the forces are acting along the x-axis. Okay, so how do we compute for the net force? How do we check if the net force is not equal to zero or is equal to zero? So in this particular example, we have an object represented as a box. This can be anything. We will represent it as box. The objects we will represent as boxes to visualize them better. And the forces, since force is a vector quantity, we represent as arrows, rather, vector arrows. The direction in which it points, yun din yung direction ng force. Okay, so what we need to do to get the net force is to sum the forces. Here is another symbol, several symbols again. This is the symbol for summation. summation of forces along the y. So summation of forces along the y-axis. That's why you have the subscript y. When we say summation, you need to add the forces. So the forces, the direction of the forces matters. Ano po? So it is 5 Newton. By the way, N means Newton. Newton is our unit for force. It's pointing upwards. Ano po? Up is positive in our convention. Up is the same as north. Down is, on the one hand, negative. Down is the same as south. So when we sum the two forces together, when we add them together, 5 newtons will take a positive sign since it is directed upwards, and 3 newtons will take a negative sign since it is directed downwards. So 5 minus 3, that would be positive 2 newtons. Positive value means it is directed upwards. The net force, the total force, the net force is directed to the north or upwards. So wherever the direction of the net force is, that is also the direction of acceleration. So our conclusion is the object will accelerate or move upwards or to the north. That's our conclusion about the object's acceleration. Let's have another example. So this one, the object is experiencing forces along the x-axis. So we have a 4 Newton force directed to the left. Left is negative. Left is the same as west. We also have a 2 Newton force directed to the right. It is positive. Right is the same as east. Okay? So if we sum the forces along the x, notice the change in subscript. The 4 Newton will take the negative sign since to the left, and the 2 Newton will take the positive sign since it is directed to the right. So if we do the algebra, negative 4 plus 2 will be negative 2 newtons. Negative 2 means it's directed to the west. So the conclusion is the object will accelerate to the west, or leftwards, will accelerate leftwards. Mas malakas yung hatak pakaliwa, in other words. Okay, this one is experiencing, there are a lot of forces acting on this one, on this object. So we have forces to the north, to the south, north and east in all of the 4 directions. So you will not combine the x and y forces. You will only sum the forces along the x and those forces along the y. So along the x, 3 takes the negative signs. It is to the left. 2 is positive since to the right, as well as this small 1 Newton force here. So negative 3 plus negative 2, that's negative 1 plus 1. It will be equal to 0. So we can say that the object is not accelerating along the x. Ano po? How about the y? We should also check if the object will accelerate along the y. So let's sum the forces along the y. So 4 is positive, negative 3 is, and 1 will be negative since pointed downwards. As it turned out, summing the forces along the y will also result to a 0 net force. All forces are balanced. All the forces cancel out. So the object will not accelerate or move at all in any of the in both of the axes, even though there are a lot of forces acting on it. Okay, let's have this sample problem or this practice problem. We have to do the same method as a while ago. Okay, so at a glance, we can see that we need to sum the forces along the x. We have a 4 Newton force, which would be positive since to the right, and a negative 3 Newton force since it is directed to the left. So summing the forces along the x, you will have 1 Newton. The net force is 1 Newton to the east or to the right. So the object will not or will accelerate to the right or to the east. Now, how about the next ones? So number 2, okay, let's do the x first since there are a lot of forces along the x. So the 5 will take the positive sign, but the 3 Newton force and the 2 Newton force will be both negative. Ano po? So 5 minus 3 is 2, then 2 minus 2, that's also a 0. How about the y-axis? The forces along the y-axis, we only have 1. So that's it, 2 newtons. So the object is not going to accelerate along the x, so the object, but along the y it would. Since the net force, there's an unbalanced force in the y-axis. Will accelerate, specifically upwards to the north. Now here, on number 3, summing the forces along the y, so we have this one is positive while the other one is negative. So that's easily 0. But along the x, this one is negative, this one is positive, as well as this one. So looking at this one, this is also a 0. So all forces cancel out. The object will not accelerate. Okay? Okay. On to the next one.